Have you ever just looked at a massive mountain range or maybe a canyon that slices deep into the earth and just thought, how did that even get here? I mean, it all feels so permanent, right? So solid. But what if I told you that our planet's surface is actually a constant epic battleground? Seriously, it's this relentless tug of war between two incredible forces: the builders, who raise up continents from nothing, and the sculptors, who are always trying to grind them back down to dust. So let's dive into this amazing geological story.
And that brings up a pretty mind-bending question, doesn't it? If our world is always in motion, always changing, from the tallest peaks to the deepest oceans, can we really say that anything on it is truly permanent? Let's hang on to that thought as we meet the two sides in this fight.
All right, first up, let's meet the planet's ultimate construction crew, the builders. These are the unbelievably powerful forces working deep inside the Earth, and they are tirelessly pushing land upwards, creating the very mountains, plateaus, and continents that we all live on.
So here's the big idea, the one thing you really need to get. We've got two opposing teams. On one side, you have the internal forces. Those are our builders. They operate from inside the Earth, creating things like volcanoes and entire mountain ranges. And on the other side, you have the external forces, our sculptors. They work on the surface, using things like wind, water, and ice to wear everything back down again.
But to really understand where the builders get all their power, we have to take a journey deep inside the planet. Because the real action, the source of all this energy, doesn't start on the surface. Nope, it begins thousands of kilometers right under our feet.
So if you could slice the Earth in half, you'd see it's not just a solid ball of rock. It's actually built in three totally distinct layers. You've got the super thin outer crust, the huge middle layer called the mantle, and the intensely hot core. And these layers are not just sitting there. They are in constant, powerful motion.
We live on that very top layer, the crust. It's the Earth's thin, kind of brittle outer shell. A really good way to think about it is like the skin of an apple. It's incredibly thin compared to the rest of the planet, and it's where all the action we can see happens. Now, right below that crust, you've got the mantle. And this is not solid rock. It's this thick, super hot layer of gooey, semi-molten stuff called magma. And it's constantly churning in these slow-motion currents, kind of like a planet-sized lava lamp. And way down at the center, we find the core. It's this dense ball of iron and nickel, and it is just unbelievably hot. This intense heat is the engine for the entire planet. Seriously, it radiates outward, it drives the movement in the mantle, and that in turn moves the crust above it. This is the ultimate power source for our builders. Okay, so how does all that heat from the core actually build mountains way up here on the surface? Well, the answer comes down to one of the biggest ideas in all of geology: plate tectonics. This is how the real heavy lifting gets done.
See, here's the wild part. The Earth's crust isn't one solid shell at all. It's actually shattered into these massive pieces called tectonic plates. And these giant puzzle pieces are floating on top of that churning mantle, constantly moving, bumping, and grinding against each other in super slow motion.
Now, when two of these plates move away from each other, that's what we call a divergent boundary. And when that happens, magma from the mantle rises up to fill the gap. It cools, it hardens, and voila, you've got brand new crust. This is literally our planet creating new land from scratch.
A perfect example of this is happening right now, deep under the ocean. It's the Mid-Atlantic Bridge. It's this huge underwater mountain range that runs right down the middle of the Atlantic Ocean, and it's where new seafloor is being born as we speak.
But what happens when plates move towards each other? Well, that's a conversion boundary, and you can just imagine it like a geological car crash happening in the slowest motion possible. The immense pressure forces the land to buckle, fold, and thrust violently upwards.
And this is exactly how the world's greatest mountain ranges are built. The Himalayas, for example, were formed, and get this, are still growing today because the Indian plate is still crashing into the Eurasian plate, pushing that land higher and higher every single year.
And then there's the third type of interaction, a transform boundary. This is where plates aren't creating or destroying crust. Instead, they're grinding horizontally past one another. But their edges aren't smooth, right? They snag, they get stuck, they build up incredible amounts of stress, and then, snap, they suddenly slip.
That sudden, violent release of stress is what we feel as a powerful earthquake. The famous San Andreas Fault out in California,
That's a textbook example of this, marking the line where the massive Pacific plate is sliding right past the North American plate.
Okay, so we've met the builders, who are busy creating these huge landforms. But the very second a mountain is born, the other team gets to work. It's time to meet the sculptors. These are the external forces that relentlessly attack the surface, always trying to grind everything back down to sea level.
Now, to understand the sculptors, you've got to know two key terms. First, there's weathering. That's the process of breaking big rocks into smaller pieces. Then there's erosion. That's the process of carrying those broken pieces away. Here's an easy way to remember it. Weathering is the hammer that smashes the rock, and erosion is the getaway car.
So first up, we've got physical weathering. This is when rocks are broken down by just pure physical force. The classic example is what we call freeze-thaw. So water seeps into a crack in a rock. Then at night, it freezes and expands, which forces the crack to get just a little bit wider. Now, imagine that happening thousands and thousands of times. It's powerful enough to split a giant boulder right in two.
Next is chemical weathering, which is way more sneaky. This is when elements like water and oxygen cause chemical reactions with the minerals inside a rock, and they slowly start to dissolve it or change its actual structure. It's the reason acid rain can slowly just erase the face off of an old stone statue.
And then, believe it or not, there's also biological weathering, which is caused by living things. I mean, you would be absolutely amazed at the power of a tiny little plant root. A single seed can sprout in a crack, and as its roots grow, they can exert enough pressure to literally pry solid rock apart. It's incredible.
So what you end up with is this amazing endless cycle. The builders push the land up, and the sculptors immediately start their work, tearing it all back down. It is a constant dance of creation and destruction that has been shaping our planet for billions of years, and it's going to keep going for billions more.
And, this quote really just nails it. The reason our planet's surface isn't flat and boring, the reason it's so varied and uneven, is because of this epic ongoing battle between the forces working inside the Earth and the forces working on its surface.
Which leaves us with one last, really fascinating thought to chew on. Just imagine for a second that the builders, the internal forces of plate tectonics, what if they just stopped? What would happen then? Well, without them, the sculptors would have free rein to wear everything down, with nothing pushing back. So what do you think our planet would eventually look like? It's a pretty wild question, and it really shows you just how vital that fiery engine at the center of our world truly is.